good. Thank you. Okay, actually, Mr. Okay, so hello everyone. My name is Michael Walker, and I'm a computer science PhD student working with the NEST team at the University of Colorado Boulder with Jack Burns. And today I'm going to talk about an alternative method for surface telerobotics using virtual reality interfaces. So as we all know, there are many instances in which our robots are located in some far away place relative to their operators, such as fighting fires in the wilderness, exploring the bottom of the ocean, or, as we like to focus around here, robots crawling across the surface of planetary bodies. And what's really exciting in this field is that there seems to be some sort of advancement almost every day that helps these robots better explore our universe, such as hardware advancements that let these robots traverse previously thought to be impassable terrain, or we have software advancements that let these robots navigate complex environments despite long communication delays using autonomous systems. But what about advancements in the interfaces that these operators are using to interact with these robots, whether direct control or supervisory control? Well, for the most part, it looks the same. It's using the same technology, these flat two-dimensional screens that we've had for decades, really, and they're doing the best they can to filter down three-dimensional data to two dimensions. So it kind of begs the question, how can we leverage these newer technological leaps we've had in other fields to better our interaction with these robots and utilize this rich data that they're returning back to us? Well, one potential solution that I'll be posing to you guys today is these virtual reality headsets. And as many as you know, one really major benefit to these headsets is that they let users see with depth. Each eye has its own lens and gets its own image, which gives the ability to see in 3D, and also have a wide field of view. And paired together, this provides a really strong sense of immersion where users can feel like they're in these virtual environments, or in our case, the real world. For previous research has used the same method, but with real cameras. So if you attach a camera to a robot and then stream the dual stereo video streams to the headset, you can feel as if you are looking out of the eyes of the robot, as if you're there in some faraway place, which also lets the users feel like they're embodying this remote robot. So with this idea in mind, our team really wanted to further explore this kind of more nascent design space, and especially in the field of space exploration and surface telerobotics. So we started by creating our own little virtual reality simulation testbed, where we have a virtual lunar surface, and we modeled our own rover, which we then could pilot along the surface of the moon for simulations. Here it is. And what's nice is that these headsets work just out of the box with these high fidelity, I'm blanking on the word, but physics simulators, which are game engines, which allow for a really rapid development pipeline, which is nice for us developers. And we can simulate things such as third-person control, traditional first-person control, looking at from the viewpoint of the robots from first person on traditional monitors or VR headsets. So here we can even sync up the user's head rotations to the control of the robot's camera, allowing for a more intuitive, natural piloting experience as if you are the robot on the surface of the moon. And these virtual reality headsets, again, we render the scene twice, once for each eye to give this feeling of 3D. So now that we have this, we can project things with depth, we can also add virtual augmented reality imagery to the scene as well. And I don't just mean two-dimensional widgets, as we're so used to with these interfaces, but we can add augmented reality that actually integrates with the environment itself, where we can have occlusion. And so this is, again, leveraging this depth that we can use for these VR headsets. Stick our hand through these things. Yeah, it's pretty cool. So we can add three-dimensional virtual imagery to these interfaces to, again, have a more rich, progressive interface for controlling these robots. Okay. So knowing that we have just these inherent benefits with this VR technology, we wanted to run a study to compare what benefits we have by just switching out these traditional interfaces, these monitors here, with virtual reality headsets. We ran our own experiment. So it was a 2x1 experiment where we either had our standard interface, again, these monitors, or a VR interface. We kept everything else the same. We didn't change the controls in the tasks we had the users perform. We didn't add any head tracking or hand tracking, just to really isolate just the addition of the VR headset versus monitor. This is with within subject design, where subjects used or completed the tasks twice, once with each interface, but we randomized the order. We had 12 subjects, 10 male, 2 female, with an average age of 22. And we evaluated, our tasks we chose were assembly tasks, simply because we have these exciting new ideas in the pipeline of potential uses of these robots on the lunar surface, such as assembling far-side radio relays. So, here's a little bit more about our experiment here. We used an industrial-grade Fetch mobile manipulator robot right here, which one would actually see in a factory floor to do fetch tasks or assembly tasks. And we attached a stereo camera and piped its information to a standard commercial VR headset, an HTC Vive here. And we ran our experiment in our lab space and controlled for lighting, so we didn't provide unnatural depth cues from the lighting ahead or above. Here is a subject actually running this experiment here. All videos are sped up just for the sake of time. And I'll go over what some of the tasks were next. So one of the tasks we ran was an object stacking task. And here we started by having users stack cubes, which is the easier of the two parts here. And we were looking at our main metric of efficiency, how quickly could they complete this task using either interface. And then we'd move on to the harder task, which is stacking these cylinders, which were much more difficult since they're skinnier, taller, etc. Another task we looked at was object sorting as well. So in a cluttered environment, users had to then sort out the blue-hued objects from one side of the table to a partition side. Again, we were looking at the same efficiency metric as we were before. So next, I'll move on to some of these results. So this is looking at time to complete. So the lower value, the better, because it just means they finish the task faster. So we have significant results with the VR headset with stacking the cubes, marginally significant results with the cylinders, again with the VR headset outperforming our standard interface. For time to complete with sorting, we didn't quite get significant results, but we can start to see this trend still appearing here. And for interface preference, we asked users which interface subjectively did they just prefer to use overall and what made the task easier, and we have the significant amount of participants choosing the VR headset over the monitor. And again, this is just using out of the box, switching the interface to the VR headset. We didn't even leverage all the additional features that we can use with this technology, such as head tracking, where we can, again, sync up the user's head movements to the robot's camera, or hand tracking to allow for a more natural experience. Users can match the end effector of the robot with their own hand for more precise movements. Full body tracking, for with these VR headsets, we're not just tracking the rotation of their heads, but we can actually get up out of our chair and move around the environment, which future interfaces could and probably should leverage in one way or another. And we can add assistive augmented reality, which I touched on before. And we can also think about integrating things such as point clouds. So for example, if I'm driving across the surface of the moon and I'm the operator and I'm seeing out of the robot's eyes and I want to stop and see, is my wheel close to a hazard on the ground? But I look down and the robot is occluding my view. What if at the same time I'm using LiDAR to create a point cloud as I'm driving, and if I have some idea of where the robot is relative to this point cloud, which I probably do, I could then switch to a different interface mode, step outside of the robot's eyes, and then walk around the point cloud in a model of the robot and like bend down and take a look to see how close this wheel is to a hazard. I could then maybe pilot the rover from that view or snap back in to the robot's point of view. And again, these are just examples of ways that we can combine different features for these headsets to create a more rich, higher performance interface for these robots. These are all things that our team are hoping to look at in the future. And I'm an intern at JPL this summer, and I'm happy to report to you guys that I've seen plenty of projects actually adopting the use of these VR headsets or augmented reality headsets, but they're typically in the capacity of simulation, playback, or analysis of previously recorded robot data in this more secondary nature. But I think it's time we start looking at using or in discovering or investigating how to use these headsets for primary operation, or at least supervision of these robots. And not to mention, we have the gateway that's going to be in place, which will allow for unprecedented bandwidths and lower latencies, where astronauts could potentially control these robots from the gateway itself instead of having to travel to the surface of the moon to feel like they're on the surface, instead they can body themselves as a robot. And finally, prepare for Mars, which is, again, our primary goal most of the time. And it's not hard to imagine that these astronauts would be able to put on a VR headset and feel like they're in some remote hazardous location as a robot from the safety of their enclosure, be able to pick up a sample and look at it as if they're there. And not to mention just that, but as a fail-safe for when autonomous systems, if they fail, or more likely when, they'll have a more powerful way to navigate these robots out of safety or back to their home base, since they're such valuable assets. So with that all in mind, our team will hopefully be able to show you more interesting, feature-rich designs in the future, as well as experiment results in future forums to come. And above all else, hopefully maybe I sparked your imagination for what this type of technology has in store for the future of space telerobotics. So with that, thanks for having me. It's a pleasure to be here.
Hi, you spoke a little bit about latency, and I was just curious how you think the results of your initial tests and preferences for the standard monitor versus VR will change with a much larger latency.
And that's a great question. So I think there's different methods of approaching this because, realistically, we won't be able to get near zero latency, at least for now or in the near future, for these types of interfaces. But we can still do work now that can help us prepare for the futures when we can get close, maybe. Or we can create a design in a perfect condition of what combination of features gives us the best performance. And then from there, we can suggest to NASA in future designs what latency we do need. Or maybe we can back out features that can maybe co-align with what we have available hardware-wise for latency drawbacks. But really, it's finding that optimal design first, and then maybe working backwards to make more intelligent suggestions as to what we should be aiming for in some way. But yes, so it is an issue, but it's something we definitely have in mind as we're doing these types of studies. Thanks.
My question's along a similar line,
Okay.
but have you thought about using this same technology to augment human exploration? So you've got an astronaut on the moon, using the VR technology, get your scientists on Earth ground, the orbiting stations, to then assist with the science aspect of lunar exploration.
Yeah, so are you thinking more along the lines of they could feel like they're on the surface with the astronauts themselves in some way, or just any old way, just using this stuff?
That is one way, but also as exactly the same as you're doing the robotics, but putting those cameras on the astronauts themselves.
Oh, yeah, I see what you're saying. No, that'd be another interesting way to do this. And actually, our team is we have close ties with the Colorado first response teams who actually go out and fight forest fires. And we're doing studies, or we're hoping to team with them so we can see how we can help with command centers using AR/VR technology, as well as humans on the field with mixed human-robot teams, and how we can bring all this technology together to hopefully bring the interface of the future for this type of work. So yeah, no, there's so many different ways we can pull this together, and that's just one aspect that you mentioned. So it's pretty exciting.
Is there, well, yeah, just very quickly. So this is Back to the Future for me. In the late 90s, I did some experiments in Antarctica using head-mounted display, head-tracked on an underwater vehicle.
Okay.
So maybe we could talk later.
Oh, I'd love to, yeah, definitely.